to my channel. Who are you?
Hey, this is not your channel. Come here.
Okay, Michael, you are the boss.
In this video, I want to show you how to recreate this awesome programmable robot called Fritz. I made it only using paper, cardboard, simple electronics, and a smartphone. I invented it to offer a cheap and simple DIY alternative to expensive robotic toys. All my materials are free to download. The electronics will cost you about $15 or Euro. This project is recommended for kids of 10 years and older. Building the robot will take about 2 hours, and programming it is an open-ended activity. The video is separated into chapters, and if you are on YouTube, you can use the navigation in the timeline to jump to different chapters. First, I will show you why Fritz is awesome. Then I will explain how the robot works. Afterwards, I will show you how to build it, and in the end I will teach you the first steps in programming the robot. So what I absolutely love about this robot is that it is so easy to recreate. There are no tools required. And by using a smartphone as the robot's brain, kids can explore the full range of app programming to not only give the robot artificial intelligence, but also character. And the best thing is, kids don't learn about programming a toy robot, they learn about app programming, which is a pretty useful skill. For programming Fritz, I used MIT App Inventor, which is completely free to use and specifically designed to teach kids about app programming. However, programming Fritz can be even simpler by just using a sequence of pictures. You will see how this works later in the video. If kids want to dive into app programming, they can start with simple instructions and add more features step by step. Kids can add character and gestures to the robot by designing different facial expressions.
I will say everything you want.
They can have the robot say anything they want with the text-to-speech module.
Let's go.
Kids can have the robot listen to voice commands.
Go ahead.
With the integrated voice assistant.
Ahead.
Every command can be scripted.
Right.
Turn around.
Turn around.
And they can use another smartphone for remote controlling. All commands are sent via an online database, and this makes the robot an IoT robot. IoT as in Internet of Things. So I could control my robot from anywhere in the world, as long as I have internet connection. And that's just what I came up with. Think about what the robot can do with its camera, or its compass, or what happens if you give your robot a call. I think possibilities are endless. There are black and white rectangles at the bottom of the screen, and there are 2 light sensors that each control an electric circuit. The brighter the rectangle, the faster the motor on that side of the robot rotates. When I take out the smartphone, you can see the light sensors. Here you can see a simplified version of the circuit. As you see, I can control the motor with my flashlight. And Fritz is doing exactly that by showing the light sensor black and white rectangles on the screen. For experimentation, you can also keep your lights on and cover the light sensor. The circuit works like that. The motor is connected to minus and plus through this transistor. A transistor works like that. If there's a small voltage applied to the middle leg, electricity can run through the transistor to the motor. A little more power at the middle leg means much more power is transported across the transistor. To control the power at the middle leg, we use the light sensor, which is a variable resistor that changes its value depending on the amount of light it receives. So more light means more power at the middle leg, which means more power can run through the transistor to the motor. No light on the light sensor means the circuit is interrupted by the transistor completely. Fritz has 2 of these circuits combined. So if this is all new to you, you will find further explanations and this template in the video description. I recommend to have kids experiment with a simple circuit so that they can explore on their own how it works. For example, you can exchange the red and black wire of the motor. This makes the motor rotate the other way around. Or you add another component instead of the motor. Or you experiment with the optional resistor down here. The ohm value of this resistor lets you adjust the threshold at which the light sensor triggers your circuit. This concept is called a voltage divider. Here you can see the circuit without the additional resistor, and now with the resistor. For our smart robot, we do not need the additional resistor, so we leave it like that. There is a template for everything you need. As always, all templates and recommended materials are linked in the video description. Besides the printed templates, you will need 2 geared solar motors, 2 photoresistors, which is the accurate term for light sensor, 2 transistors, 4 button cells, 2 binder clips, conductive tape, some craft supplies, and cardboard. I will use hot glue in this video because it is fast. So the programmable robot is an upgrade to my easy robot from my last video. I recommend that kids start building the easy robot first and then upgrade it. But it's no problem to start with the smart robot right away. The easy robot is very simple and you can add a remote control and even solar power to it. And it is the perfect basis to upgrade it with my smartphone extension later on. To get full instructions on how to build the easy robot, you will find a link to my last video in the video description. Once the easy robot is finished, follow these simple steps to upgrade it. Snap off the front from the motors. Detach all cables. Cut the overlapping part of the circuit. Now prepare the new circuit for the smart robot. Then trace the circuit with conductive tape. I link to my basics video in the video description if you want to learn more about working with conductive tape. Make sure that neighboring tracks of conductive tape do not touch each other at close areas. Attach a strip of tape at the marked spots where the batteries will go. I explained the reason for that in my easy robot video. The light sensor has to be put through a small hole to the other side. Attach the light sensor's legs with conductive tape. Stick a small strip of transparent tape on top of the light sensor's heads. This prevents the light sensors from triggering touches on the display. The transistor has a round and a flat side. The orientation is very important. The template shows you how the transistors have to be attached. When upgrading an easy robot, cut the bottom part of the template. Then glue the circuit to the back of the robot. Think of the light sensors as the robot's arms. Fold them to the front of the robot. Then separate the wires of the 2 motors and attach them like shown in the template. Now glue the front to the motors. Attach a small piece of cardboard to the bottom. Now hold your smartphone in place and have the light sensors hug your smartphone tightly. Glue both arms to one another with tape. Now add non-transparent tape covering the light sensors. This prevents light from outside to interfere with the sensors. I recommend to add this little design element. Glue it to the bottom and attach it to the light sensing arms. Then bend it inwards. This not only looks great, but also blocks light from the outside, which is important. Now make a quick test. Add 2 batteries to one side and put your robot in bright light. Fritz should start driving. If this works, put your smartphone inside the robot and make a quick test with my test video. So we see the robot can go left and right. It can go forward and also stop. Perfect. If your robot is not working, you will find troubleshooting tips following the link in the video description. If your robot is working, you can try it with all 4 batteries. This gives the robot more power, but it is important that you insert the batteries as shown in the template. The minus poles of all batteries have to point downwards. Instead of using my sample video, kids can create their own videos, and I want to show you how. I think using a video is a great way to introduce kids to the basic concepts of programming without the need to learn a programming language. This is possible because all we have to do is to show black and white rectangles where our light sensors are. The easiest way for kids to create their own video is by using a stop motion app. I link to the one I use in the video description and also a good tutorial on how to use it. The app is free and very intuitive to use. Kids should have no problem creating their own video. To do that, you can use my paper animation template, or you just use colored paper. Cut out the screen area and the black and white rectangles. The gray rectangles are experimental to make the motor rotate slower. Also, cut out eyes and mouth. Now create your first picture. I choose 2 white rectangles to make my robot go forward, and a smiling face. Start your app, create a new movie and take a picture. Now proceed with the other pictures. One to make the robot turn left, one to make him turn right, and one to stop. Here you can see a good result. Pictures should be in focus and showing a bright white rectangle while also showing very dark black. It won't be perfect, but that's okay. When you have all 4 pictures, you can use the options menu to set your movie to 1 frame per second, which means that each picture will be shown for 1 second. Now we can program our robot. And for our purpose, we can define programming as a way to give a sequence of instructions to our robot. We do this by putting our pictures in the order we want. Every picture is an instruction for our robot, like go left or stop. So after you took all the pictures, touch any one of the pictures to bring up a lot of options. Here you can cut and paste the picture to move it around and change the order of instructions. You can also copy a picture and put it somewhere else to use this instruction again. Since every instruction is only 1 second long, I recommend to repeat every picture a few times in a row to give the robot some time for driving. There is no limit for how long your chain of instructions gets. In the end, you can save your animation as a video and open it using your photo gallery. You might need to set the rotation and adjust the brightness of the screen for best results. Here is an example. If you or your kids like paper crafting, I do have a template for a cute robot body. It's the same as the body of the Easy Robot, so check out my older video for that. The only difference is that you need to cut a window for the smartphone screen. When finished, your kid's robot will just look amazingly cool and they built all of it themselves. If you play around with your robot a lot, you might want to add a little on-off switch to your robot. To do this, just cut a little gap into the circuit and connect or disconnect it with a small strip of conductive tape. That way, you don't need to attach or detach the batteries all the time. Instead of using pictures, Fritz can be programmed with any programming language that is used for programming apps. You just need to show black and white rectangles on the screen and Fritz will start moving. Turn around. But as I showed earlier, there are much more possibilities than just have your robot drive around. I have so many ideas for that I want to make a whole series of videos to show you how to use MIT App Inventor to program this little robot. If this is interesting to you, subscribe to my channel and leave your ideas on how to program Fritz in the comments. And if you like my work, consider supporting me on Patreon, where I share even more resources about paper circuits and how to use them to teach kids about technology. And if you want to be prepared for future projects, check out my Vault Paper Scissors box. I'm not selling it, but I put together a shopping list of materials that I use. Getting these will prepare you for all my upcoming projects and also past projects. So that's it. To get started, check all the links in the video description. Thanks for watching and see you next time. One more thing. Batteries are best stored in their packaging to avoid short circuits. And don't forget to recycle all components before you decide to throw away your robot. They can easily be reused for future projects.